Welcome back to another CommCon Virtual 2020 session. This time we're with Matthew from the Matrix project. He's the CEO of New Vector. New Vector might have changed their name by the time that this video comes out, but I'm sure Matthew will talk about that. Matrix as a project is really, really cool. I use it every single day to talk to other people within the industry. And Matthew's going to talk to us about peer-to-peer matrix and how that kind of fundamentally changes things potentially. So I'm just going to pass it over straight to Matthew, and then I'll catch up with you all afterwards. See you soon.
Thanks, Dan. Thanks for having me on CommCon this year to talk about Matrix. And indeed, as you say, I'm here to talk about peer-to-peer Matrix because where we're going, we don't need servers. So first of all, I should probably give people an overview of what Matrix is. Apologies if you've heard this many times before. I'll try to go quickly through it, but we do need the context to understand why the peer-to-peer stuff is so exciting. So Matrix today is a large open network for secure, decentralized, real-time communication. So we are attempting, and I think succeeding, to be the real-time communication layer of the web itself. So Matrix is simple, really simple HTTP APIs that allows you to send and receive real-time data of any kind packaged up as JSON objects. So you can use it for instant messaging, you can use it for VoIP, you can use it to negotiate WebRTC both for one-to-one calls and say within a VR or AR world, or you can even use it for IoT data fabric. We have people controlling the color of their light bulbs via Matrix, or streaming telemetry from their car, or even doing MIDI over Matrix. So it's an open protocol. We standardize it as an open standard released by the matrix.org Foundation with open governance, and anybody can run a server and participate in the open network, much like you can run a SIP or XMPP or email or web server on the public internet. So our mission is to create this global decentralized encrypted comms network, which provides as open a platform for real-time comms as the web does for hypertext, documents and applications. So we really feel that there's a missed opportunity in the VoIP space where there are so many proprietary, siloed, centralized products out there, like Slack or WhatsApp or Discord or Telegram or whatever, where everybody is communicating today, and you just miss the open ecosystem like you have on the web. And we know why this is, because let's face it, it's quite hard to build these communication apps. And when people have historically, they go and lock them in as a commercial proprietary system and derive value and sell themselves to Facebook for $19 billion. However, we want to break that pattern and go and provide the infrastructure that anybody can build on as just part of the fabric of the internet itself. One way of thinking of Matrix is if you have a whole bunch of different communication silos, here, Slack, Discord, Telegram, etc. Matrix can be a decentralized network connecting them all together. You obviously have native users on Matrix, and today we're mainly going to be talking about native users, or it could be a bridge through to an existing system like Discord. So on one hand, you have people using an app like Riot, like people who are participating, say, on the CommCon server for the hallway chat at the moment, using Riot as one of the green dots. And they could be talking to a user on a different server, like matrix.org, for instance, which I'm on, which then has bridges through to the Freenode IRC network, and I think 10 other IRC networks right now. So that is how today's Matrix network looks. The really interesting thing technologically is that no single party here owns your communications. There is no single centralized server controlling the conversations. There is no single point of failure. And the very act of talking to somebody on a remote server replicates your conversation to them. So it's kind of subversive decentralization that it is impossible to talk to somebody remotely without forcing you to share the ownership of the conversation with them. It's very similar to Git architecturally, in that everybody with a copy of a Git repository who is participating in Git has a complete copy and autonomy over that, rather than there being a centralized server like you had with Subversion or CVS or RCS even. Architecturally, as I said, you get native clients, they talk to servers. The servers today talk in a full mesh, And then you have application services, which are like clients on steroids that allow you to build bridges and other value-added functionality that effectively have root or super user privileges on the server which they are connected to. And then finally, you have identity servers for now, which are a way of optionally mapping email addresses and phone numbers, MSISDNs, through to your matrix IDs so that people can discover you on the network like that. In terms of what you get feature-wise in the spec, it's basically all the features you would expect from a modern communications app. You get synchronized, decentralized conversation history as a first-class citizen, and it's super important to understand that Matrix isn't a message passing protocol. Instead, it's a history synchronization protocol. So all of these rooms on your different devices and other people's devices are in the process of synchronizing both the history and key value state that describes that room between the servers participating. So many people ask what the difference is with, say, XMPP, and at least from my perspective, XMPP is primarily passing stanzas of XML or data, could be XML, could be JSON, whatever, between different clients to servers and servers to clients, whereas in Matrix, you're literally synchronizing a data structure instead, rather than just a message, with eventual consistency between those nodes. Everything is a group message. Even DMs are effectively a room with two people in them. Everything is end-to-end encrypted by default, as of a few months ago, for private conversations. We've spent an awful lot of time on E2E, but we won't go into it now. Its UX has historically been a bit clunky, but it hopefully has got a lot better whilst we turned it on by default and is continuing to improve. I mentioned already that you can signal VoIP over Matrix for WebRTC. Looks and feels a bit like SIP, but without any of the edge cases. So you have trickle ice by default, you don't have re-invites, you don't have offerless invites. It's much, much simpler to invite with some candidates, add some more candidates, answer, media flows, hang up. That's basically it. You get some server-side push notifications and search, surprisingly hard. Nowadays, you also get client-side search for end-to-end encrypted rooms because you can't search server-side unless you do homomorphic encryption. You get read receipts, typing notifications, presents, read receipts, and unread counts. Unread counts are surprisingly hard. We've just changed again how they work in the last couple of weeks. So they're calculated server-side rather than client-side. You get a content repository, and you can store arbitrary account data for users per room. In terms of the architecture, the main deliverable is the spec itself, which defines the HTTP APIs that you can use to send messages from clients to servers. Clients here on the top, we provide JavaScript, iOS, and Android API SDKs, both on Kotlin and Java on Android, and Objective-C and JavaScript TypeScript on the web. And then on the server side, we have two reference implementations. The old one, Synapse, written in Python 3 and Twisted. The new one called Dendrite, which I'll talk a lot about in a minute, written in Golang. We also have lots of bridges and applications that we write ourselves. And then the purple stuff here are many, many different services written by the community. And there are now hundreds, if not thousands, of projects built on Matrix in the community. Some really interesting servers are, for instance, Conduit, used to be called Rumor, which is a Rust implementation that is incredibly performant. Doesn't have federation yet, but has pretty much everything else. We have client-side Rust clients like Fractal, C++, ones like Neko, Quaternion. There's a new generation that I haven't mentioned here, written in React Native, like Ditto Chat, or Swift UI, like Neo. Basically, any environment you can think of now, somebody will have written an SDK or a client to hook into Matrix because it's just so easy to send and receive messages there. To give an idea of what the network looks like in size, I've graphed the total addressable users on Matrix over the last 6 years since we began in September 2014. And as you can see, it's accelerating in this slightly alarming curve. We're actually up to 18.5 million addressable users. And this is literally looking at unique Matrix IDs that we can see on our systems. But a similar shaped graph exists for active users and messages sent, etc. So the network is steadily and inexorably growing. In terms of other stats, we see from the matrix.org server about 5.5 million messages a day across, I think it's more than 4 million chat rooms now. more interestingly, there are 45,000 different servers out there, and less than 30% of the traffic is going through the original server on matrix.org. Lots of people complain that we have a default large server, the original one, which we use to basically onboard people, but in practice, not least because it tends to be a bit overloaded, people move out onto their own servers. And so we see the network decentralizing quite nicely. Finally, at the bottom, I mentioned we now have 5 different governments who have adopted Matrix. It turns out the Matrix is very popular for governments who like end-to-end encryption and self-sovereign digital sovereignty for their communications, as well as interoperability in both the local network and the wider network. The ones we've announced are the entirety of the French state, and more recently the German Bundeswehr, the Ministry of Defense there, where the entire German military have adopted Matrix as their day-to-day comms platform. And there are 3 others which we haven't announced yet, and we will as soon as we get permission. But it's very exciting to see Matrix in this sweet spot as a way to connect the public sector together. So enough background on Matrix as a whole. Let me talk about peer-to-peer stuff specifically. Why would you want peer-to-peer? Well, the main reasons here are to let users have full autonomy over their data without being sysadmins. Let's face it, it's great to say, hey, on Matrix, you can control your own data as long as you're a professional Linux or Unix sysadmin who can run a server with adequate security to host your own conversations. Everybody else is just out of luck. So what we want to do is to really double down on the promise of Matrix to empower users to control their own communication by letting them run it on their clients themselves. Another massive advantage is that it simplifies onboarding. That if you're a plain old user and you install a Matrix app like Riot, you don't have to pick what server to use. I mean, you don't get into trouble for picking a default server. Instead, you just exist. You go and start looking for other nodes on the network. Could be via multicast DNS, could be by AWDL, which is the Apple technology that powers AirDrop, or it could be by going and manually specifying some peers to connect to elsewhere on the network if you don't have any other local ones. But critically, it's not a compulsory, you have to have an account to get running. And as a result, this will give us internetless operation that is incredibly desirable for environments where you just don't have internet for whatever reason. Really excitingly, it forces us to protect metadata because your metadata for your conversations would only exist on your devices. It gives support for client-side bridging, which is particularly interesting if you're bridging to a system that doesn't really like being bridged. And here, the responsibility for the bridging lies squarely with the user if they're running that bridge on their server, which is running onside their client. And an interesting side effect is that it's also forcing us to solve a lot of hard problems, particularly multi-homed accounts, because a huge issue right now is that even if your conversations in Matrix are decentralized, your account sits on a single server. And if somebody attacks that server or attacks your account there, again, you're screwed and you have to set up shop somewhere else. Whereas in peer-to-peer, you're forced to support the ability to migrate your account or multi-home your account between the various devices where you're logged in. And that solves the wider problem of account portability between different servers. It also forces us to make the home servers smaller if they need to run on a client without destroying disk space and battery. Forces us to do smarter routing algorithms, because today Matrix is a full mesh routed network. So if I send a message to matrix.org and it's in a room with 1,000 other servers participating, it does 1,000 parallel HTTP hits to those servers to replicate the messages. Whereas here, that would be stupid if your phone had to talk to every other device in a room to send a message. So it forces us to do smarter routing algs. And finally, you want this to be as low bandwidth as possible. You don't want it to be chatting away, synchronizing lots of data over HTTP. It would be much nicer to use a more efficient protocol like CoAP or Quick or some other very lightweight solution. And the other really desirable aspect to this is that it allows us to not change the clients or the bots or the bridges at all. So you can take today's Riot code base that everybody has been working on for years and years now, or any other Matrix client, and just connect it to the local server rather than the one that is running in the cloud, for want of a better word, somewhere else. So to give a bit more context on this, today's network can be thought of as a client that talks over HTTP to a server that talks over to another server. And this was me trying to sketch out the architecture of Matrix of years to come back, now 2 years ago in 2018. The next phase of this was to consider, hey, what would happen if we offloaded some of the heavy lifting onto a daemon, which would handle your end-to-end encryption, and you could talk locally to it. It could do search and other heavy lifting stuff, but it would still go and talk through to a server. And we've built this thing now called Pantalaimon that you can use if you have a simple HTTP matrix client that doesn't know anything about encryption, like curl, and you just want to talk with encryption through to matrix. So it acts as a kind of shim between you and the wider network. Pantalaimon is written in Python. It's currently being rewritten in Rust. And one of the interesting things there is that we end up getting a Rust SDK out of it, which means that you can actually start reusing the heavy lifting bits of Matrix, including the end-to-end encryption, client-side as a reusable library, and that can be run in browser. There's a new project done by the community by a guy called MT Arnold, called daydream.im, which is using the Rust SDK in browser to have an entirely Rust Matrix web client. Or it could be running in a different client, like WeChat, for instance, is now able to embed the Rust SDK, and we hope that Fractal will move over to it too. But critically, all three of these things are still client-server model. But what would happen if this Pantalaimon-style daemon as a concept evolved until it was actually a full-blown home server? If you literally took that home server and ran it client-side and spoke, I don't know, HTTP to it from your client, or even if you embed the home server all the way through into the client. So these two on the right are what we're going to talk about today. So the way we've approached peer-to-peer is kind of unusual in that rather than just setting out and saying, right, we're going to add peer-to-peer to Matrix, let's do it and ship it and done, it's very much an open area of research. It's not that clear what protocol stack we should be building on because there are many options and they all have different pros and cons. And we have some luxury of time to try to get this right. So we have a small R&D Black Ops unit within NewVector, which is the company the core Matrix team has set up to fund Matrix development. And Neil Alexander and Keegan are the developers on the team today, and myself to some extent. And what we've been doing is building fairly advanced proof of concepts on an entire stack to see how it works and test in the field. So the first one that we've done is to do standalone Dendrite with Go libp2p. So libp2p I'll talk about in a minute. First of all, let me introduce Dendrite. So Dendrite, as I mentioned earlier, is our next generation Golang home server. And this is a diagram of the various different components inside Dendrite, because it's a very microservice architecture with 1, 2, 3, 4, 5, 6, 7, 8, 9 or so different components that build up the server. So they're split into the public-facing components and the internal ones. And so you've got a sync API that lets users receive messages. You've got client API that lets users send messages, federation API that interacts with other servers, and media API that sends and receives files and content. And then internally, you've got various different services which represent rooms, ephemeral data units like presence and typing notifications, federation, talking to application services, managing your keys, and managing device keys and managing server keys. And they're all linked together by a variety of different HTTP APIs. Now, the really interesting thing for Dendrite is that we built it to scale massively, and all of these things can shard as horizontally as you like. So you could get hundreds of millions of users on a Dendrite server. Perversely, the same property means that we can also shrink it down in size quite effectively. And the other interesting thing is that these components are actually linked together using append-only Kafka logs. And there are actually only 6 of these in production. All the other ones are linked via HTTP APIs. But for instance, the sync API feeds data from the client API. The room server, which represents the rooms, feeds it into the sync API and also into the client API. and so on and so forth. So this allows you to restart the components separately, as well as adjust how horizontally they scale. And it's a really, really interesting architecture to play with. So what we did with Dendrite was to do the thought experiment of what would happen if we swapped out its HTTP transport from Go with libp2p, HTTP layered over libp2p. So libp2p is modular network stack from the guys at Protocol Labs who created IPFS, and it gives you lots and lots of building blocks like Academia, DHT, distributed hash table. You get pub sub mechanisms, you get discovery, routing, transports. Supports WebSockets, it supports WebRTC data channels, it supports raw network activity, implementations in lots of different languages. And so for this demo, we just put plain old HTTP 1.0, I think, layered over libp2p. So before, you've got clients which talk to servers, which talk to servers, which talk to clients via plain old HTTP. But in the P2P world, you can end up talking through to a local standalone Dendrite, which would then use this HTTP stack over libp2p to basically have the same topology. And this was our first proof of concept, and we showed it off back at FOSDEM in February. And other than needing good Wi-Fi between the servers, it works pretty well as an initial proof of concept. However, we don't seriously expect people at this point to be installing a standalone home server on their laptop, or for that matter, on their phone. So for the second experiment, things got a bit more exciting, and we wondered what would happen if we embedded Dendrite into your web browser. So Dendrite's written in Go. What would happen if we compiled it to WebAssembly, and then we provided a special Go HTTP transport that would shim the HTTP traffic into the web browser via JSLib-P2P. The reason for doing JSLib-P2P rather than Go libp2p being that it can use all of the native functionality available in the browser environment. Then you need somewhere to store your data. At the time, Dendrite was Postgres only, but we ported it to also support SQLite, and we went and implemented a SQLite driver backed by JavaScript that was exposed, though, as a Go API, so Dendrite could use it from WASM. And then you put the entire thing in a web service worker, so that's a background thread, effectively, that is disconnected from the UI of the browser tab that you're in. And they're really, really cool, and that they can intercept HTTP traffic from your browser as if they were a real server. So you literally end up with a virtual server sitting at the same URL space as your client that doesn't really exist. Instead, the traffic is shimmed and redirected into the WebAssembly Dendrite, so you literally don't change a single line of the Riot app itself. It's just talking to this local WebAssembly client. So architecturally, it looks like this. You've got your service worker, you've got Dendrite and WebAssembly, you've got your SQLite, which is in practice being stored in IndexedDB in the web browser, ironically not using the structure of IndexedDB, it uses it as a file system, so it's a bit of a hack to say the least. But you then have a library called Go HTTP libp2p.js, which exposes your HTTP traffic over libp2p using the same protocol we had in the same demo before, using rendezvous.matrix.org as a service to go and discover the other clients there. Because as I'm sure you know, you don't get native P2P APIs today in a web browser, so you need to find some kind of system to coordinate for the clients to discover themselves. And in fact, for this demo, what we use are WebSockets. So you go and talk WebSockets through to Rendezvous, which then relays your traffic through to other clients, which is a bit of a shame because it obviously acts as a single point of failure. But in future, we could extend this to support WebRTC data channels so that you just do the discovery and negotiation via Rendezvous over WebSocket, and then you would talk directly WebRTC between the two. The reason we haven't done that yet is both because we moved on to the next experiment, but also because service workers can't talk WebRTC yet. So we would have to shim that back over into the browser in order to then talk WebRTC. And honestly, the transport bit isn't the exciting bit. It's going and getting all the glue in the middle working. So in terms of our original thought experiment, that shows you how we filled in for our first two experiments the idea of Dendrite and Go lib P2P for a standalone local Dendrite, and then embedding that Dendrite into your client for Dendrite and JS lib P2P as a stack. And you can play with, this one, the Dendrite JS lib P2P right now. If I go out of my presentation quickly, and I go to p2p.riot.im, should probably do it in an incognito window. Oh no, it's still there. So that is me logging straight into my P2P account, and you can see on the live libp2p Go network, there's a whole bunch of people talking in there. They have these terrible matrix IDs, all called @p2p, and then this thing here is a IPFS libp2p hash, which identifies their node. At the moment, we don't have account portability, so it's one user per device. And if we look at one of the messages sent here, it's sent from a great big ugly peer-to-peer client ID, and you've got an event ID and a typical matrix message. So that is how that looks in practice. If I open up my console here, there's lots of errors due to 404s, but somewhere at the beginning of this, we should have seen a whole bunch of Dendrite Go logging. And yeah, there we go, incoming requests to my path/users key can go package, blah, 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 matrix.org util, as the service worker sits there chatting away. And in fact, you could narrow it down to Dendrite SW, which, well, if I were use the console, I would now be in the scope of that service worker. Or I can go into my application here and look at my service workers, and here it is, saying that P2P, let me zoom in so people can see, p2p.riot.im has got my Dendrite service worker that's been running since the 3rd of June, so over a month, and that is the tab, this one here, which is currently connected to it. And we could go and look at its logs, we can unload it or reload it, and do all sorts of good stuff like that. So honestly, it's a really exciting demo to be able to run an entire home server in your browser, and you don't even need to sign up if we go and start a new tab. In fact, it doesn't work in an incognito window, but if I cleared this and went back in, you just get dumped straight into the network using rendezvous.matrix.org, which you can go to, and apparently its certificate needs a prod. So to go into the final experiment, this is brand new. It came into existence over the last week or so. So this is a world first here on CommCon, showing an entirely new architecture for the peer-to-peer work. And what we did was to consider Yggdrasil rather than libp2p as the transport and the peer-to-peer component of the network. So many people will not have heard of Yggdrasil. It's quite an obscure project. And what it is an experimental end-to-end encrypted overlay network, which typically looks a bit like Tor, except it's not onion routing, and it's designed for encryption, but not privacy per se. So by default, you run an Yggdrasil node on your machine, and it gives you a new network interface, which allows you to talk to other machines via IPv6, which are connected to the Yggdrasil network. And the way it works is that it forms a spanning tree over all of the nodes on the network. So literally one great big tree, which is why it's called Yggdrasil, after Norse mythology, and the tree of life that connects everything together. And the really fun thing is that it supports arbitrary underlying network transports. So if any of your devices have any way to talk to one another whatsoever, and that could be AirDrop, AWDL, it could be on the same network, it could be a transitive connectivity via other devices which are multi-homed, it will find a way to go and glue you into that wider network. So it supports disconnected networks out of the box. If it can talk to the wider network, it will. If not, it just lets you talk locally. And it supports the idea of multi-home devices so that you can be bridged from one network to another one via Yggdrasil. It routes by using the tree. So it looks at the coordinates on the tree of where other nodes are, going and sharing the information about the topology of the tree via a very simple chord-based DHT doesn't actually store anything in the DHT, it just uses the node, the peer information itself to discover where other peers are. And then based on the distance on the spanning tree, it decides who to connect to. Really important to understand that the packets don't actually follow the topology of the tree. Instead, it's just using the coordinate space of the tree to inform which peers it routes via. Apparently, this is inspired by Robert Kleinberg's geographic routing using hyperbolic space. Interesting things is that it doesn't give you automatic peering management or a naming system. It's really quite bare bones. You have to manually select your peers unless they can be discovered spontaneously. And as I said, it's typically used as an IPv6 overlay network, but you can go and put apps on top of it too, which is, of course, what we're trying to do here. And finally, your addresses, much like libp2p, are a hash of your encryption key, although apparently you can fall back to DNS. And it looks like this. That is literally a picture of Yggdrasil as taken by one of the monitoring websites. If you just Google for Yggdrasil map, it will come up, as of last night when I was putting together the slides today. As you can see, it's not that big. It's only about 1,000 nodes on the public network. It's a pretty small experimental project. You have a route to that tree, which is a node called Bifrost currently, and then you have many other people connecting out in this tree with different topologies or different bushiness of the tree. And it's mainly people like us experimenting with it today. So architecturally, how we can plug this in is to go and use the Go Yggdrasil stack as a Go library, put it inside Dendrite, and then we can run it in this instance, we embedded it onto iOS, putting it physically within Riot iOS. So we now have a version of Riot called Riot P2P, which you spin up and uses Yggdrasil rather than HTTP to talk to the rest of the network. And to demonstrate this right now, I'm also running a plain old Dendrite on my laptop on the same network with Yggdrasil, the same stack in it. And for the actual network transport, we've been a bit more interesting. We're using HTTP3 on top of Yggdrasil, mainly because Yggdrasil is a packet-based system, although it uses TCP for connections between the nodes at the moment. It itself thinks very much in terms of packets, and Quick is HTTP3 and is built on UDP rather than TCP, and it also gives us multiplexing for free. So let me try to actually do a live demo of this. If I go back to my browsers, then I have a room here called It's Alive. And if I pull up the membership here, this is connecting through, well, first of all, I got a horrible matrix ID for a change. And if I go into my settings, there it is, my horrible ID. And look at where I'm connected to. I'm connected to localhost on port 8008, and that is a Dendrite which is sitting down here. And there are a bunch of people in this room. Some of them are on the network here in the office. Some of them are wider internet, but all of them are connected via Yggdrasil. So if I go and say hello world here, then go back to my logs in the background, my Dendrite has gone and sent that out to the wider world. Now, if I screen share from my iPhone here, you can see I have Riot peer-to-peer running. Done. Hopefully that's coming through all right. And here it is. Hello world. And I can respond testing from iOS. And in the background, you can see that the testing from iOS messages come in. Now, it'll be hard to see on the video, but the latency on this is incredibly good because obviously it's just going on my local network straight from my iPhone 10 through to my laptop and back again. And you can see I've got typing notifications, and you can see the Dendrite logs there going and showing the messages bouncing back and forth. So it's really, really quite nice. Let me see if anyone else is out there. Hopefully he's got some notifications turned on and can get involved in the demo. So Neil is both a maintainer of Yggdrasil as well as a developer on the P2P Matrix stuff. So it's perhaps not that exciting or not surprising that we're playing around with Yggdrasil in this context. But I'm going to try to do a demo that we've never done before live, which really shows things off interestingly, which is that I have here my old and very broken, smashed iPhone 7. And let me see how my iPhone 7 is behaving. What I want to try to demonstrate is connectivity between the devices not even on the same network. So my iPhone 7 Plus is connected to the guest Wi-Fi here in the New Vector office. My iPhone 10 is on the non-guest Wi-Fi, so they cannot route to one another. And moreover, I haven't gone and configured a internet peer on this instance. And if I go and send a message, you can see me saying test there on my iPhone 7, hello, and it is going through to the browser, as you can see. Now, if I go and look at the settings, first of all, let me go back here. I'm connected to 4 different peers. You can see we've added in the number of peers which you're connected to. So I'm guessing that's going to be my laptop and my iPhone 7, which it will have discovered via AirDrop or AWDL. So this is super cool that just that physical proximity to another Apple device don't even need to be sharing the same network. I can discover it and start talking to it. And also on this one, I've gone and put a static peer into the configuration so that this has internet connectivity to the wider Yggdrasil network, even if there aren't any other peers locally. But you really get the idea that it is properly discovering clients on the local network, as well as being able to talk through to the wider Matrix one. So that is our very latest demo. The idea as time goes on is that Riot in the relatively near future could end up by default including a home server, and it will start off peer-to-peer. And if you do want to go and host that information server-side, you can. But it's a total paradigm shift. I mean, I'm mumbling about it because it's so hard to express, but we're literally transitioning the network from being pure client-server federated with decentralized rooms to being, it could be totally peer-to-peer, and instead the servers become almost a special case of the network for when you want to have a well-defined position for your data to reside on the network in a given jurisdiction or a given availability or whatever the requirements are. So the advantages here for Yggdrasil is the AirDrop connectivity, multicast DNS to discover people on the same LAN, and all the things I mentioned earlier. Disadvantages are that nobody's got Yggdrasil working yet in browser, but it should be quite easy to do. We compile it to WebAssembly, and then you use WebSockets or WebRTC as a transport. The technology is experimental. It has a couple of potential failure modes. What happens if somebody attacks the root of the network? And there are ways to mitigate that, like source routing could allow the connections to continue working even if the network itself gets disrupted. And it doesn't at the moment give us a way to help us with routing, although it could be very interesting to imagine how you could start to use the topology of the Yggdrasil tree in order to route messages more efficiently around the place between rooms. If this did run in a browser, and I hasten to add this is total science fiction, me going and writing ideas of how things could work, something we could do is to ship Yggdrasil nodes inside the Matrix home servers on today's network. And your typical web client could bootstrap by talking to its normal web home server and then talking to Yggdrasil via that server's node, so connecting to the overlay network via the home server. And then that obviously has the disadvantage that your client has still got a single point of failure on that server. But you could then give the users the option to select which other peers in their conversations they could connect in. So just as you can choose who to VoIP call today, imagine if in Riot you could select which users you wanted to connect to directly. And it means that you would lose some privacy. They might be able to see your IP address if you're literally directly peering with them. But on the plus side, there is no longer anybody else on the network path between you and them. So it gives you the ability to talk to them without any internet connectivity or without any middleman whatsoever. And in terms of how you migrate from today's network to this, well, as long as today's network evolved to using peer-to-peer identifiers throughout, you just mix them together and the servers just become server-side peer-to-peer nodes. So going back to that diagram again, this Dendrite and Yggdrasil world could support both local home server and embedded home server style environments. So where do we go from here? The path forwards is we still have some experiments to do. We want to properly evaluate the gossip sub in the P2P, which is a really interesting routing algorithm that allows you to do fan-out routing of information throughout the libp2p network. So it could solve our full mesh routing dilemma. Also interested in looking at Hyperswarm, which is the DHT from the DAP project. A big thing I've glossed over here is what do you do if you're sending from one device to another device and the other device isn't turned on right now? You need somewhere to store and forward your data. You need to do it in a metadata protecting way. Again, this is an open area of research, but we're looking at various different approaches for having blinded store and forward servers to solve this. Worst case, you can just use a home server, but then that will leak metadata. We need to switch everything over to using keys rather than old school DNS-based matrix IDs. We kind of have that already in the demos, but it doesn't support multi-homed accounts and it's a bit hacky. We need to make that a lot more sophisticated. Multi-homed accounts is obviously critical, so you can have the same identity on multiple devices. Then we need to figure out low bandwidth transports more effectively than just using QUIC. That could be by tuning QUIC, could be by using Tcoap, who knows. Lots of work to be done on smarter routing. Can we, for instance, use social reputation data from Matrix to decide who to route via? If your partner's devices are online, would you prefer to route your data via them rather than some random other person on the net? Who knows? Can we use Yggdrasil's or the underlying network's topology, whether it's gossip sub or Yggdrasil's spanning trees, as smarter routing topology? Imagine if every room was a mini Yggdrasil tree forming its own spanning tree to provide more efficient routing. And how do we bridge to today's matrix? Touched on that on the previous slide. And finally, imagine a world where this is part of your OS. Imagine where you have a matrix daemon sitting in GNOME or Mac OS or iOS or Android or whatever environment, which would both handle all of the heavy lifting of end-to-end encryption and indexing in matrix, push notifications, as well as actually being your peer-to-peer home server itself. And I think that is a really exciting world where everything can have a matrix D running in the background, providing this functionality, and you just have Matrix as a service locally available for whatever apps and whatever use cases you might have on that device. So in terms of the project as a whole, we have a massive release due on probably July the 15th, which is probably the date that you're listening to this at, roughly, where we are releasing Riot X on Android, and we are rebranding all of Riot and NewVector and Modular, our hosting platform, under a new name. Also, lots and lots of work on the user experience on Riot, particularly on Riot Web, to make sure that people can migrate from Slack without feeling lost. Got to rework the community system, how you group rooms together, add extensible profiles as a really useful feature that we don't have. We already spoke about account portability and decentralized accounts. Finally, better reputation and trust and safety management in the network to mitigate spam and abuse of all flavors. And finally, we're going to get back to threading, which we began about 3 years ago and paused whilst we fixed everything else. But we will finally be in a position to hook up, hopefully, later on this year. So that's where Matrix is at today, where it could be in future with peer-to-peer, and where we're going in the wider project. Thank you very much for listening to me ramble on. And thanks again for having me on CommCon, and thank you, CommCon, for using Matrix as the communication fabric for the conference this year.
Thanks so much, Matt. I forgot to mention earlier that the Matrix Foundation / NewVector are one of our gold sponsors this year. So thank you for supporting us and enabling all of this to happen. I hope you all go and watch their 5-minute preview type thing that will be linked to at the end of this talk. Yeah, Matrix for me is like this crazy thing. I remember Matthew talking about it at a conference, like, I don't know, it must be like 4 or 5 years ago. Or maybe, yeah, it feels like that. That sounds about right.
Yeah, I think it was.
And I was like, what the hell is this thing? Like, surely it won't like take off. It's far too complicated. And then I've been using Matrix properly for probably 2 years now, like not just on and off, not just playing with it, actually using it. And then I think probably about a year ago now, I started running my own home server. I was like, I need to get off of matrix.org. Yes, there's some problems with it, and like they're fixing all of those. But let's be a good player within the ecosystem and take my traffic off. And that's awesome because I can start doing other things. I can make bots. I can get webhooks, and so Matrix as a platform is really, really interesting, and it's been amazing to see it grow from what it was the first time that I heard Matthew talk about it to this thing that is actually truly incredible now. So I want to just move straight over to Q&A. There's loads of questions that I could ask, but it's better that we do it with everyone else. So let's just move over to Q&A over on Riot. So Riot won't have changed its name for us just yet. So head on over to riot.commcon.xyz. The link will be in the description below, where we'll do live Q&A with Matthew and maybe some of the other Matrix team members if they can turn up, because we're all federated. It's great. So yeah, let's go over there. And I'll see you all in a minute. And don't forget to watch their 5-minute preview video, which will be linked to in a minute. Thanks again, Matthew, and thanks for sponsoring.
Thanks, Sam. It's been a pleasure. Thanks. Bye.
Don't go anywhere quite yet, though. We've got to say thank you to all of our sponsors. Without them, none of this would have even happened in the first place. So for our platinum sponsors, we've got Toulouse, Voxbone, and Ciara. For our gold sponsors, we've got the Matrix Foundation, Vonage, Sangoma, Telviva, and Loway. Our silver sponsors are Aptosay, Pion, Telco Bridges with ProSVC, Avoxy, 8x8 with Jitsi, and FirstCom Europe. Then we've also got community sponsors, QXIP and Cycol Systems. Without any of them, this would never have even happened. You wouldn't have had all of this free content on YouTube. So go say thank you to all of them. Go look at what they provide, what services they offer, and have a conversation with them all over on Riot, riot.commcon.xyz. The link will be in the description below, along with links to all of our sponsors. You can go and watch preview videos from all of our gold sponsors right now over on YouTube. The links will be somewhere over here. All I've got to say is thank you to all of our sponsors, and I'll see you over on the Q&A shortly. Cheers.